Hi guys, it's Keith again with a video on inverse functions, specifically the exponential function and its inverse. I'm going to start with an example, and that is y is equal to 3 times 2 to the x minus 1 plus 1. And I do what I always do when finding the inverse. I swap my y with an x and my x with a y. That means that x is equal to 3 times 2 to the y minus 1 plus 1. I take that plus 1 over, and that's going to be x minus 1 is equal to 3 times 2 to the y minus 1. Divide both sides by 3. X minus 1 over 3 is equal to 2 to the y minus 1. And you'll remember from logarithms that we can now make y the subject of this equation by using log. So we use log of base 2. That 2 comes from this 2 is equal to y minus 1. And that means that log base 2 x minus 1 over 3 plus 1, getting rid of that 1 with the y, is equal to y. So that's the inverse of that logarithmic function. That exponential function. And the inverse of an exponential function is always going to be a logarithmic function. So here's the exponential. F of x is equal to 2 to the power of x minus 4. And this is what the inverse looks like. So you can see that it's just flipped about the line, y is equal to x, as with all other inverses. So let's look at the domain and range of an exponential. So the exponential of f of x is equal to 2 to the power of x minus 4 has the domain, x is an element of all real numbers. That means that the x values go from negative infinity to positive infinity. And the y range says that y is greater than q. So in this example, our q value is 4. And the y range goes from here. So this graph is never equal to minus 4. It's only ever above that because we have an asymptote at minus 4. For the inverse, log base 2 of x plus 4, which I found algebraically similar to the previous example, the domain x is greater than q. So you can see that our range and our domain have swapped around. So x must be greater than q, and our q value is still minus 4. It's still this, say, minus 4. And our range is y is an element of all real numbers. So you can see that these are related in that way. And that's all there is for exponential functions and their inverses.